Chapter 6, Section 6A1 is all about function operations. So today's lesson we're going to add, subtract, multiply, and divide functions, and we'll explore domains just in case they have any restrictions. So just a quick recap of what's going on this slide. Anytime that you add, subtract, multiply, or divide, it doesn't matter whether you write it as one quantity or just those two things separately. So just be familiar with the fact that they can write it both ways. Anytime you add, subtract, multiply, or divide functions, you have to consider domains. Domains consist of any restrictions that occur in any of the functions involved, as well as the answer. There are two different restriction kinds that you have to worry about. The first is the denominator of any fractions or division, and then also square roots. For denominators mean that you can't have 0 in the bottom. And so the restriction that comes from that is that you can't have any denominator equal to 0. For square roots, they need to remain positive. In this chapter, we're still dealing only with real numbers. And so anytime you have a radicand, it has to be either 0 or positive, which means 0 or bigger. So you'll notice in each of these examples, they'll give you two functions, most often f and g, and they'll ask you to do operations on them. So in number 1, f of x is 5x plus 1, and g of x is x minus 4. For the first one, I'm going to do f plus g of x. The f function is 5x plus 1, and the g function is x minus 4. All I need to do is add them. Now, when addition is involved, the parentheses aren't really necessary, so you might be a little bit more comfortable if you write it without the parentheses. All you need to do is combine like terms. 5x and x is 6x. 1 and negative 4 is negative 3. That's the expression of f plus g of x. Looking for domain. Domain always starts the same way. X is an element of the reals. If there are restrictions, you write them last. So there's no division going on here, no fractions with denominators, and no square roots. So there are no restrictions. You can just close the domain. On the other side, I'm going to do the f minus g of x operation, which means I take the f function, 5x plus 1, and I subtract the g function, x minus 4. In subtraction, it's important that you get the order correct and also to distribute any negatives. So 5x plus 1 will remain the same, but when I distribute that minus, I get a minus x plus 4. If I combine like terms, 5x minus x is 4x, and 1 plus 4 is 5. Taking a look at domains, x is an element of the reals. I don't have any division or fraction, so that's not an issue, and I also don't have any square roots, so there are no restrictions from that. Number 2, f of x is 4x plus 7, and g of x is the square root of x plus x. So on the left, I'm going to do f plus g of x, the first thing they ask for. That means I'm doing 4x plus 7 plus square root of x plus x. And again, when you're adding operation, when the operation you're doing is adding, you really don't need parentheses, so I'll take a second and write it without. And find any like terms. I have a 4x and an x, which is 5x. And then just recopy the rest. This is the expression that you get for f plus g of x. For the domain, x is an element of the reals. Here, we don't have any division, but we do have a radicand, a square root, and it's right here. It also occurs here and here. They're all the same, though. So what you want to do, because I need that to be positive or 0, is you take that radicand, whatever it happens to be, this one happens to be an x, and you set it greater than or equal to 0. That's what positive or 0 means. Now, in your domain, we put this long line, it means such that, and then close it off. So the domain reads, x is an element of the reals such that x is greater than or equal to 0. That just means that you could pick any x value you want, as long as it's a real number. You can plug it into the problem, and it has to be 0 or bigger. On the other side, we're going to do f minus g of x, which means we're going to take the f function, 4x plus 7, and subtract the g function, square root of x plus x. I'm going to distribute that negative sign. I get 4x plus 7 minus the square root of x minus x, because I distribute that negative. Combining like terms, 4x minus x is 3x, and then recopy the plus 7 minus root x. For the domain here, I have x is an element of the reals, such that I have restrictions. I have radicands all over the place. I need that radicand x to be 0 or larger, so x is greater than or equal to 0. All right, number 3. My f function is 3 minus x. My g function is 1 over x. So on the left, I'm going to do f plus g of x. That means I'm taking the f function, 3 minus x, and I'm adding the g function, 1 over x. Now this one's a little different because it requires a common denominator. Anytime you have fractions, you need to write them as a common denominator, and the common denominator between all of these is an x. Technically speaking, these things are over 1, and this right here is over x, which means my common denominator is an x. Anytime you get common denominators, any term that's missing, the denominator needs it. So this 3 needs an x, and that x needs an x. 3 times x is 3x, then there's a minus sign. X times x is x squared, then there's a plus sign, and then the 1. So this is the expression that I get if I add them. Domain on this one's a little different than the rest we've done so far. I do have restrictions. I have restrictions because I have a denominator. Here's a denominator right there. It happens to be the same one that's there. I need to make sure that that denominator, which is x, is not 0. Anytime you have a denominator, it can't be 0. So my domain here will be x is an element of the reals such that x is not 0. For f minus g of x, I'm going to take the f function, which is 3 minus x, and subtract the g function, which is 1 over x. If I subtract, I'm going to write it for a second just like this. I distribute that negative. Common denominator here is an x, which means the 3 needs it, and so does that x. So what I really have is 3x minus x squared minus 1. That's the expression I get for the quotient. For the domain, x is an element of the reals such that any denominator anywhere in the problem needs to be fixed so that it's not 0. All of the denominators are x, so x can't be 0. You'll see an example later on where it's something a little different. All right, number 4. F of x is negative 2x plus 8, and g of x is x minus 10. The first thing they want me to do is f of x plus g of x, which looks a little different, but it's really the same thing. I'm still taking the f function, negative 2x plus 8, and adding the g function, x minus 10. The parentheses here aren't needed, so I will take a second and rewrite it without them. Combine like terms, negative 2x plus x is negative 1x. 8 minus 10 is negative 2. For the domain, x is an element of the reals with no restrictions because I don't have denominators and I don't have square roots. Be really careful with the second one. This one says g of x minus f of x. And when it comes to subtraction, order matters a lot. So I'm going to put the g function first this time, which is new, and then the f function, negative 2x plus 8, second. First thing I'm going to do is distribute the negative. I get x minus 10 plus 2x minus 8. Combining like terms gives me 3x minus 18. For the domain, I don't have any restrictions because I don't have division and I don't have square roots. We're going to move on to multiplication and division. So if you take a look at number 5, here's the f function, 5x plus 1. Here's the g function, 2x minus 4. So the first thing they want me to do is f times g of x. That means 5x plus 1 times 2x minus 4. This is a binomial times a binomial, which requires us to FOIL. 5x times 2x is 10x squared. 5x times negative 4 is a negative 20x. 1 times 2x is 2x. And 1 times negative 4 is negative 4. I'm going to write it in standard form, that's what we prefer, and combine like terms. So I get 10x squared minus 18x minus 4. For the domain, x is an element of the reals, but there are no restrictions because I don't have division and I don't have radicals. On the other side, I'm doing f divided by g of x, which means I'm going to put the f function on top, 5x plus 1, and the g function on the bottom, 2x minus 4. You should always double check to see if you can factor either expression. I can technically factor the bottom into a 2 times x minus 2, but it wouldn't cancel or reduce with any of the sums or factors on the top. So that is my final answer for the expression. The domain here is a little trickier. We do have restrictions because there's a denominator. There's division going on. So take a look at that denominator. I'm just going to underline it in orange so you see where it's coming from. I need to make sure that that denominator, 2x minus 4, is not 0. So set it up like an equation, but put a dash through the equal sign to say that that's not what I want. And you solve it the same way. If I add 4 to both sides, I get 2x is not 4. And if I divide by 2, I get x is not 2. That's my restriction. I don't want x to be 2, because if x is 2, I get that green denominator to be 0, and that's a problem. Number 6, this is my f function, and that's my g function. First thing I'm going to do is f times g of x, which means I'm going to take 2x plus 3, that's f, times g, x squared plus 4x minus 5. This requires a double distribution. First thing I'm going to distribute is the 2x. 2x times x squared is 2x cubed. 2x times 4x is 8x squared. And 2x times a negative 5 is a negative 10x. And I'm going to distribute the 3. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times negative 5 is a negative 15. Put it in standard form and combine all like terms. So I'm going to put 2x cubed first. 8x squared and 3x squared is 11x squared. Negative 10x plus 12x is a positive 2x, and then I'll recopy the minus 15. For the domain on this one, there aren't any radicals or any division, so my domain doesn't have restrictions. The other side, I'm doing f divided by g of x, which means on the top is f, which is 2x plus 3. And on the bottom is g, which is x squared plus 4x plus 5. You have to double check to see if you factored the denominator, would it cancel with anybody up top? So I'm going to take a second and do that in orange, because I'm going to need to do that anyway for my domain. X squared plus 4x plus 5 factors into an x plus... Oh, hold on. I made a mistake. I figured it out. This is a minus. Sorry about that. That's a minus. I've miscopied the g function. This factors into an x plus 5 and an x minus 1. So neither of those factors matches the purple 2x plus 3 up top. So this ends up being my final answer for the expression. However, for the domain, I do have restrictions because I have a denominator. If you take a look at the factor form, x would equal here a negative 5 and a positive 1. Because those two answers are what gives me 0, those are the two values that I can't have in my domain. I can't have my domain be -5 or 1 because they would both make my denominator 0. All right, number 7. Here's the f function. Here's the g function. First one they want me to do is f times g of x. That means I'm going to do 4x plus 7 times the square root of x plus x. I'm foiling. 4x times the square root of x is 4x root x. And it's kind of gross, but just let it be that way. 4x times x is 4x squared. 7 times the square root of x is plus 7 root x. And 7 times x is 7x. If you take a look over that expression, there are no like terms, so that's just your final answer. For the domain, I do have restrictions because I have square roots. So if you take a look, this radical matches that radical, matches that radical. They're all just x. I need to make sure that that's bigger than or equal to 0. Anytime you have a radicand, it needs to be 0 or higher. For the division, be careful, g of x specifically needs to be on the top, which is actually helpful because when you rewrite that, g of x is the square root of x plus x. Had that been on the bottom, you learned in the last half of the chapter that you would have to rationalize. The bottom of this fraction is f of x, which is 4x plus 7. You're never going to get anything to cancel because of the radical, so that's your final expression. The domain here is pretty intense, though. So we're going to take care of one thing at a time. First thing I'm going to take care of is this radicand. I need to make sure that x is greater than or equal to 0. So I'm going to start kind of a tally on the side and see what happens. I also need to make sure that this denominator, 4x plus 7, is not equal to 0. If I solve that for x, subtracting 7 gives me 4x doesn't equal -7. And dividing by 4 gives me x can't be -7 over 4. That expression isn't necessary because I've already said that x has to be bigger than or equal to 0. So I don't need that as my domain restriction. All I need is the greater than or equal to 0. Had that second value been a positive 7 over 4, I would have had to write x is greater than or equal to 0, then put a comma, and write x can't be positive 7 over 4. So that way somebody doing the problem would know that they could pick any real number bigger than 0 as long as it wasn't 7 over 4. All right, number 8. Here's the f function. Here's the g function. This one's a little different. They want me to do 2 times f of x plus g of x. That means 2 times -2x plus 8 plus this g of x, which is x minus 10. So I have a little bit of cleaning up here to do. First thing I'm going to do is distribute the 2. Gives me -4x plus 16. And then recopy plus x minus 10. Combining like terms gives me -3x plus 6. The domain on this one's pretty easy because I don't have restrictions. I don't have any square roots, and I don't have any division or denominators. Here's the f function, x squared plus 8, and here's the g function, 4 minus x. They want me to do negative g of x plus 4 times f of x. All right, negative g of x means negative times the quantity 4 minus x plus 4 times the f function, which is x squared plus 8. In this first set, I'm going to distribute a negative, which gives me -4 plus x. And in the second, I'm distributing a 4, which gives me plus 4x squared plus 32. Combining like terms and in standard form gives me 4x squared plus x, and -4 and 32 gives me 28. Again, for my domain here, I just have x as an element of the reals with no restrictions because there's no division and there are no square roots. The multiplication of the you try it is pretty straightforward. You just have to FOIL. No restrictions because there's no division or square roots. The division, though, is significantly harder. There are a couple things I want to point out. The first is that if you factor the top, the f function, you get x plus 3, x minus 3. And the x plus 3 on the top can and should be canceled with the x plus 3 on the bottom. And all you're left with is x minus 3. The problem is that x plus 3 on the bottom that you canceled still needs to be considered when finding restrictions. So if you take x plus 3 and you set it not equal to 0 and solve, you should find a restriction on the domain that x can't be negative 3. That's kind of tricky, and most often students forget to do that. For the second you try it, all you need to do is 2 times the f function minus 3 times the g. Pretty straightforward. Combine like terms and clean it up, and there are no restrictions on the domain.